we can be really good at every single part of this problem. You have done a lot harder problems than what's here on this one. We got this Joanna girl jogging, and they give us her velocity at certain times right there. And it says estimate V prime 6. So this is your V. You want to do the derivative of that at 16. So going between 12 and 20, where 16 lies, write down those 2 points, and then just find the slope between those 2 points. Because the derivative is slope, no calculator on this problem there, so just reduce that a little bit. And then since you're doing the derivative velocity, that's your acceleration units right there. Okay, so just do your slope. You got part A down. Now letter B, it says explain the meaning of this definite integral, the integral of the absolute value of velocity. You can explain that meaning. You should be able to explain the meaning without even working this problem out. When you look at your blue packet, you only have 2 things. If you see the integral of velocity, that's your displacement. That's your net result. If you see the integral of the absolute value of velocity, that's your total distance traveled. That's it. So the instant I see the integral of the absolute value of velocity, that automatically is going to be the total distance in meters that Joanna jogs in those 40 minutes right there. So boom, you got that first part down already. And then to approximate it using a right Riemann sum. So let's pretend for an instant the absolute value bars isn't there, and you have to do a right Riemann sum. With right Riemann sum means you start at the right side of your interval. That'll be your first height, and then this would be your first base. So if I'm doing a right Riemann sum normally, I'm going to go 150 times the distance between 24 and 40, which is 16. And then I go plus the negative 220 times 4 plus 240 times 8 plus 200 times 12. The only difference is instead we have the absolute value bars. So that just means if you have the negatives there, make them positive. But if those absolute value bars are not there, you would include those negatives as part of your answer. So I just wanted to mention that. And that would have been her displacement, her net result, but the total distance she traveled. So right Riemann sum, I'm going to go 150 times 16. And then since it's an absolute value bar, I'm going to go a positive 220 times 4 plus 240 times 8 plus 200 times 12. That's how I'm getting that, okay? And then rewatch that other video where I explained how to do the Riemann sums without the pictures or without the rectangles. I kind of mentioned that in the Google Doc there. Hey, I explained how to do that without the picture. So practice that on your own. And then there's no calculator on this one. So try to think factoring when there's no calculator to make those numbers smaller to you. You ain't gonna try and go 150 times 16 and whatever. I factor out a 4 because I saw the 16, 4, 8, and 12. So I factor out a 4. And I knew it like 154 or 600. I did, add addition here, whatever. You can see my arithmetic there. Make that work in your head. A lot of times I'll do this stuff in my head, and then I just want to be extra cautious because it's like a testing situation. So I'll do like the old school multiplication just to like triple check myself there. I'll kind of just do it in my head and, look it over again, think about it, and then get that answer. And then that's just going to be your meters right there, the total distance that you travel. And then C and D, now we got this new character, this Bob old guy riding his bicycle along that same path. And then it gives us his velocity equation right there, and it wants to find his acceleration. So we know to go from velocity to acceleration, you're just going to take the derivative of that. So I took the derivative and then plugged in 5. Boom, there's your 15 meters per minute squared. And those are always our units for the acceleration. Now on letter D, it says average velocity, and this is your velocity equation. So you're not, I know when we say that word average, a lot of times we'll do that slope formula, right? But you're not going to do the slope formula here, because if it gives you a cupcake equation and it says find the average number of cupcakes, you use your average value formula. So it gives you a velocity equation that says find the average velocity, use your average value formula. If it would have given me a position equation and then find the average velocity, that's when I would do my slope with that position function, because then you would have like meters on the top and you divide it by the minutes on the bottom, and it'll turn into like a derivative of slope for you. And if you do the slope of this, then you're doing like, you're doing like acceleration units there. So again, if it gives you a kind of an equation like cupcakes and it says find the average number of cupcakes, that's meant to do your average value formula. So in between 0 and 10, so remember your average value formula is just this guy right here, according to your blue packet, 1 over b minus a times the integral from a to b. And then just please practice this without the calculator. Notice I made these pretty straightforward without the calculator, but again, I'm seeing the 10s. I factored out that 10 right away and make that number a little bit smaller right there. Okay, and then just be careful with your arithmetic. Anytime you use the average value formula, the units will always be the same as whatever it is that you're integrating. So those units are in meters. That's the velocity, so that's going to be in meters per minute. And then so that's why I'm sticking with meters per minute. It says the average velocity, just on average, that's how fast that bicycle is going to be traveling there. Tacos, taquitos con queso.